Lesson 1.3. So in this lesson, we're going to take a look at solving equations when we have variables on both sides. Okay, so we're going to see that some equations have one solution, and sometimes we get equations that have lots of different solutions, and some that don't have any solutions at all. So all kinds of different equations. So one type of equation we're going to look at is an identity. And if you think of, what is your identity? What does it mean to have an identity? Well, an identity here is something that's always true, okay? Or an equation that is always true, okay? Always true, no matter what the variable is, okay? So that makes an identity. So we're going to see that. We're going to run into that situation because we can have an equations. Here's some simple equations. X plus 1 equals 5. Well, that has a single solution when x here is 4. That's true, of course. Okay. Sometimes we can get equations like this. X plus 1 is equal to x plus 1. Well, that's true for all variables x. Doesn't matter what you put in here. Pick any number you want. Negative 32 plus 1 is equal to negative 32 plus 1. Of course it is. That's always true. And then we have equations like this that, so this one here was always true. And then we can take equations like this where we have, 5x, let's say x plus 5 is equal to x plus 1. Well, is that ever going to be true? Is it ever going to be true that 5 more than a number is equal to 1 more than a number? No, that's never going to be true. So this has no solutions. All right, well, let's get into some examples to see what we can do. So some basic steps here. Okay, we're going to have 3 steps. When we're solving equations, we want to solve equations with variables on both sides. That's what we want to look at. So we want to simplify both sides. That's the first important thing. Okay. Then we're going to use inverse operations to collect the variables, or we're going to isolate the variables on one side. Okay, and then we'll divide to finish off. Okay, so we're going to simplify and then collect the variables on one side. So get all the variables by themselves and then solve from there. So here we got a couple equations. We've got 4x plus 3 plus 2x on the left, and 3 times 2x, or x plus 2 on the right side. So first thing we got to do is we got to simplify. Don't start moving things around yet. Just simplify. 4x and 2x add to 6x. Okay, here we're going to distribute 3x plus 6. Now we want to get all the variables on the one side, and we want to get all the constants on the other. So let's move those x's out of there. And that gives us 3x plus 3 equals 6. Now let's get those 3's out of there. We want to get the constants off of one side and over to the other. Doesn't matter which side they go to, as long as all the variable terms end up on one side and all the constants on the other. So we have 3x equals 3. And then our last step is to solve by dividing. And so x, because these cancel, these make 1. Okay. And we can plug it in to check that out to see, does that really work? Well, does 4 times 1 plus 3 plus 2 times 1 equal 3 times 1 plus 2? Well, this right side here, this is 9. And this guy over here is 4 plus 2 plus 3. It's 4 plus 5, basically, which is also 9. So, yes, it checks out. Okay. How about this case? A little different equation. we got to first of all simplify. So let's distribute. We have 2y minus 6. And we got to distribute here, but what are we going to distribute on the right side? Do we distribute just the 3? 3 times 2y, 3 times 1? Well, that's close. Okay, but we got this negative to deal with here. So this right here is really a negative 3, and it helps to think of this as plus a negative 3, because subtracting 3 is the same as adding negative. Now that reminds us that we need to distribute negative 3 to both of these. So let's do the 5, bring down the plus sign, and negative 3 times 2y is negative 6y. Negative 3 times 1 is negative 3. And we're just putting the parentheses to separate, to kind of keep it clean here. Okay, let's clean it up. 5 plus negative 3, that's 2. And 2y minus 6. Now let's isolate the variable. We want to get all the y's on one side. Doesn't matter which side. But let's go ahead and get rid of them over here. That leaves us 8y minus 6 equals, and that is 2 plus 6y. And so we got 8y minus 6. Let's go ahead and add 6. We've got 8y. 8, so y would be divided by 8, and y is going to be equal to 1. Alright, so we got what y is, plug it in, and this is going to be 1 minus 3, which is negative 2 times 2, which is negative 4. Now plug in 1 here. 2 times 1 is 2, plus 1 is, so 2 times 1, I'm going to put 1 in there. It would be 2 plus 1, that's 3. 5 plus 3, negative 3 times 3, that's negative 3 times 3 would be negative 9. And so 5 plus negative 9, which gives us a negative 4. Okay? So we're good. Okay. Now, a couple more examples here. Okay. Equations that don't always have a solution. Okay. Equations that are true for all values. That's called an identity. Okay. All right. So we want to solve these to see if they're always true or never true or they have a solution. Okay, so let's try this out. First step, simplify. So 5x plus 3, can't do anything with that side. And we have 3x plus 3 plus 2x on the right side. So combining like terms, we get 5x plus 3, and on the left 5x plus 3. Now that's enough to kind of see that they're exactly the same, but just kind of prove it, subtract the 5x, and 3 equals 3. Well, that's true. In fact, it's always true. It doesn't matter what x is. So we say all real numbers. Okay. One more here. Let's see. So here we're going to distribute 2x plus 10 on the left-hand side. Just, well, let's go ahead and simplify it here. So we got 3x minus x, that's 2x. So we got 2x plus 4 equals that. Okay. Now we want to maybe get rid of the x's. Subtract 2x, and that's interesting. We have 0 plus 10, which is 10. Is that true that 4 is equal to 10? No. So we say there's no solution. When we get something that can never be true, no solution. Okay? So lots of different ways to write these steps, but here's some basic steps for solving equations. 1, simplify each side. Again, that's each side separately. Don't move anything side to side. Then step 2, isolate the variable. Get it all by itself with addition and subtraction. Then step 3, solve by division and multiplication. Okay, and then check your answer. So that's our general steps. Let's try a couple. Well, actually, I'm going to turn it over to you here. Okay, so you try these, follow those steps, and see how you can do on these extra practice. Simplify, isolate, and solve, and check. Simplify, isolate, and solve. And then go back and plug it back in real quickly to check it. So try the extra practice, see what you can come up with.